Hey everyone, welcome to another Open Cluster Management Community Meetings. It is February the 3rd, 2023, and today's agenda we're gonna have Q Hao, who's gonna talk a little bit about the AddOn Lifecycle Enhancement. So Q Hao, please, without further delay, please take it away. Thank you.
Okay, let me share my screen. Sorry, I have to restart the app.
No problem.
Yeah, please wait for a minute.
No problem. While we wait for Queen Hao, Patrick, I CC you on a PR, a draft PR regarding the security report. I think it's part of the requirement to have some of that fill out if we want to move on from CNCF sandbox to CNCF incubation. So whenever you have some cycles, please take a look at that. Thank you so much.
Will do. Thank you for the notice.
Yep, we can see your screen now.
Okay. Today I want to talk about the work we have worked for a long time. It's about the add-on lifecycle enhancement. It's mainly about the rollout strategy for the add-ons. It's based on the previous work on Qiujian's install strategy. I see some motivations. So the motivation is now the add-on agent is controlled by the add-on manager, and when the add-on manager upgrades, all the agent will upgrade automatically. And in some cases, we are seeing the requirement that the user want to do rolling upgrade to add-ons to the new version. For example, upgrade the add-on on a group of cluster first. And if everything works fine, they can upgrade all the cluster to the new version. That's the background. And in this proposal, we want to enhance the existing cluster management add-on and main cluster add-on API to support the version-based add-on installation on a group of clusters. And also this API can reflect the installation upgrade and rollback progress, including the version progress and complete time. This proposal does not include the how to enhance the existing add-on framework. There are 3 use cases for this. The first is, as a user, I can configure a desired version of my add-on to install for a given managed cluster. And I can know the status, including the version, progress, and complete time. And also, as a user, I can configure desired version to upgrade my add-on, and I can also know the status. And the third story is I can configure my add-on to roll back to a desired version, and I can also know the status. So to achieve this, we have this proposal. It's based on the install strategy and also the add-on configuration. The changes including first is we add a new API called AddOn Hub Config. This API is a cluster scoped API. We can use it to do some global configurations. For now, we can define the desired version in this API. It's very simple. And next is we do some enhancement to the cluster management add-on API. We remove the supported version and then move it to the managed cluster add-on status. And we add a default config section to list the default configurations. And inside the install strategy, we add a nested rollout strategy to control the add-on upgrade behavior when the configurations change. Let's first see the add-on spec. Here we add a default configs. It represents the default add-on configurations when all the add-on can have the same configs. And the user can override this default configs by defining some config in the install strategy for specific clusters. Install strategy is the same, and inside it have a tab. Tab it can be manual and placement. A placement is a group of placement strategy. And if placement is a list of placements, that's the install strategy tab is placement. And all the clusters selected by each placement will install the add-on. There is a possibility that one cluster can belong to multiple placements. And in our design, it will only apply the strategy defined later in the order. That is to say, the later strategy overrides the previous one. And in the placement strategy, we have placement is a reference to a placement. It has a name and namespace point to a placement. Configs is a configurations that the main cluster add-on used during the install. A user can also override this config by updating the managed cluster add-on directly. An important change is we nested a rollout strategy to the placement strategy. It defines the behavior to how to apply the add-on configurations change. And this rollout strategy only watches the configs defined in this cluster management add-on. It won't watch the configs for the user-defined configs. What I want to introduce more is about the rollout strategy. It has a lot of fields. The first is the strategy tab. Here it has the 3 tabs for now. It's update all, rolling update, and rolling update with canary. Update all means when the configurations change, all the new config will update to all the clusters at once. And this is also the default strategy. The second strategy is rolling update. It means when your configurations change, it will apply the new config to the selected cluster with the concurrency rate defined in a field called max concurrently updating. Another tab is rolling update with canary. This means when the config change, first the controller will wait and check if add-ons on the canary placement selected cluster have applied the new configs and they are healthy. If yes, they will continue to apply the config to all the clusters. A field called last known good config spec will record the last successfully applied spec hash from the canary placement, so that if your config changes during or when the canary is passed, but before all rollout is done, the current rollout can continue because the last known good is still the previous one. And when the previous rollout is done, it can then continue to update to the latest change. Below is an example for how we use it. For example, the cluster have spec hash A, and at this time the canary is passed and the last known good config spec hash would be A, and all the clusters are rolling out to A now. During the rollout, the config spec may change to B, and this time the existing cluster will continue rollout to A because the last known good is still A. And when the route to A is done and the canary has passed the route to B, the last known good will change to B, and then all the cluster will start rolling out to B. Another point is that the canary placement does not have to be a subset of the install placement. The canary placement is more like a reference for the controller to finding and checking if the canary cluster have checked the path before upgrading all. And to trigger the rollout of a canary placement, you can define another rollout strategy with tab rolling updates, or even you can manually update the add-ons on those clusters. Next, I will have more examples for this 3 tab. In this field, we have two field for tab rolling update and rolling update with canary. Inside the rolling updates, you can define the max currently updating. It's similar to the Kubernetes definition. For example, if it's defined to 30%, so once the add-on config change, it will first pick 30% of the clusters to adopt the new config. If everything works fine, it will continue on the remaining clusters. And for rolling update with canary, it's additional placement. It's a reference to a canary placement. And other fields are same to the rolling update. Above are the changes we made to the many cluster add-on spec. And in the status, we add a install progression to represent the current configuration and conditions for each placement. In the install progression, you can see we have a placement ref. It's the same as what you defined in your spec. It's used as a key for each install progression. And the config reference lists the current add-on configurations, and also have conditions to describe the status. For the config reference, we have a list of fields. In each config reference, it has the resource group and the resource name, namespace, and desired configs by hash. This is calculated from your configs. And also have a field called last known good configs by hash. This means the last known good configs by hash is for fresh install and rollouts tab with update all and rolling updates. This field is actually the same as the last applied configs by hash. And for the rolling update with canary, this field comes from the canary placement. It means the last successfully applied config by hash of your canary placement. And the last field is last applied configs by hash. It records the spy hash when all your corresponding many cluster add-on are applied successfully. Okay, that's all for the changes we made to cluster management add-on. Next is we also made some changes to the many cluster add-on status. We moved the supported config to the status as a hint for user to know which type of config they are allowed to override. And in the status, it also have a list of config reference. It's a bit different from the cluster management add-ons configuration. It has group resource, namespace, and the desired config spec and hash and last applied. config by hash, but don't have the last known good because it's not used in this resource. Okay, next change is we add an annotation called config by hash to the manifest work. We use this to match the manifest work and configure to a many cluster add-on. Also for the conditions, we add a new condition tab called progressing. This will be used in the many cluster add-on to reflect the progress. And this condition will also be used in the cluster management add-on. Instead of progression, it will be a summary of each placement. Its status could be true or false. True means the configurations are being applied, and false means are applied successfully or failed. And the reason it could be installing, install succeed, install failed, upgrading, upgrade succeed, upgrade failed, and waiting for canary. Okay, that's the introduction to the API change. Next, we'll have an example. Below is an example. For this example, this tool could be used to generate each resource. So each resource name will have a char-based suffix. In my example, I use XXX and YYY to represent the suffix. First, let's see the configuration. For example, in this add-on, its desired version is 1.0.10. You can define an add-on hub config like this. And in the cluster management add-on, you can define this hub config as a default config in this field. And in the install strategy, the tab is placement. You can first define a placement called AWS placement and define some other configs in this field. And also you can define your route strategy. Also, as I want to route the config change for AWS, so I define the tab as rolling update with canary. And inside the section, I point to a canary placement. And with this definition, when the configs change in the future, the controller will first try to find if the configs in canary placement have applied to the new config. If yes, the controller will continue to upgrade all the clusters in AWS placement. And to trigger the routes for the canary placement, user need to define another section for the canary placement. It have the same config as the AWS placement, and it has its own route strategy. In this way, when the config change, the canary placement will first upgrade. And if everything works fine, the controller will continue to upgrade the remaining clusters. And in the status, we have an install progression to trace all the changes. It matches each placement. The name and namespace is the key for each install progression. It also have name AWS placement, and another is canary placement. And in the config reference, it has record the configs group resource name and last desired configs by hash, last applied configs by hash, and last known good. And also it has a condition to as a summary for all the managed cluster add-on status. For the canary placement, it's the same. In this example, you can see for the canary placement, it has 100 clusters and they are all upgraded successfully. So all the desired last applied and last known good are YYY, means the upgrade is done. And in the AWS placement, you can see the desired is YYY, last known good, this comes from the canary, so it's also YYY. And last applied is still XXX. It's because the cluster is still upgrading. And in the conditions, you can see it's still upgrading. The AWS has 400 clusters and 200 are upgrading. That's all for the cluster management add-on. And with the definition in cluster management add-on, a managed cluster add-on will be created by the install controller. And it will also updated by the route manager. The route manager will maintain the config reference for each managed cluster add-on. Or in this example, the desired spec hash is synced from the cluster management add-on. And last applied config will also be updated by the route controller when the installation is done. And the condition shows the status for each resource. In this example, the installation is done, so desired and last applied are both YYY, and conditions is upgrade succeed. And also for the manifest work, you can see we have a annotation called config spec hash. It matches the configs defined in managed cluster add-on so that the controller can update the conditions based on this manifest work. And below are more details for how we implement it. I will do a quick introduce to this. The admin is actually responsible to install the add-on, and he can also modify the install strategy and rollout strategy. For a normal user, he can override the configurations by updating the managed cluster add-on. An add-on manager is our existing component. It has 3 works. First, it's responsible to update the supported version in the managed cluster add-on. And also, since it has the permission to access all the configs, it has the responsibility to update the desired config spec hash in the cluster management add-on. And also, it's responsible to watch the managed cluster add-on and create manifest work for each add-on. Install controller is a new component we introduced. It's responsible to watch the cluster managed add-on and create a managed cluster add-on with a correct desired config spec hash. An important component we introduced is called route controller. It's responsible to first, it's responsible to sync the desired spec hash from the cluster management add-on to managed cluster add-on. For a non-canary route, it will always try to keep the desired spec hash in MCA be aligned with the desired config spec hash in the CMA. And if it's a route upgrade, the controller will try to keep the desired spec hash in MCA be aligned with the last known good. And the last known good comes from the canary placement. The route controller is also responsible to update the main cluster add-ons last applied config by checking the manifest work. It match the manifest work by the annotation and also check some conditions. If everything is fine, the controller will update the last applied config spec hash in MCA. And with last applied updated, the controller is also responsible to update the conditions. It will compare the last applied with desired and to know if it's installing or upgrading, if the install is done or not. Below are some details. Another thing is the route controller is also responsible to update the install progression. Or for non-canary route, when all the add-ons route to the desired config spec hash, it will update the last applied and last known good to the desired config. And for canary routes, when all the add-ons route to the last known good, it will update the last applied to the same as the desired spec hash. And it will also update the conditions. This condition is a summary for the managed cluster add-ons conditions. Okay, that's some details for the implementation. And next, I have 3 examples. First is for fresh install example. This example, the desired version is still 0.10. So to install add-on, you can have this config. And also you can define a CMA like this. Or you can define some default configs here. And also for each placement, you can overwrite the default configs. And when it's created in the install progression, you can see what configs actually used. For AWS, it's first it has 2 desired config spec hash, the AWS config xxx and the hub config xxx, and has a condition is installing. For the GCP, it's the same. And when the resource is created, a managed cluster add-on resource will be created. In the config reference, it has the same desired config spec hash. And when install is done, it will update the last applied field. And the add-on manager will watch the MC and generate a manifest work for it. And when all the MC is installed successfully, the route controller will update the CMA's install progression. Since all is installed successfully, all the last applied and last known good will also update to XXX. And in the conditions, you can see the install is done. And this is for the fresh install. And if user want to only upgrade add-ons to a latest version, for example, they modified these configs and the desired version changed to 0.11. And the spec hash changed to YYY. In this time, if you use some tools like customize the tools, the name in the CMA will also change to YYY like this. And in the install strategy, your undesired config also change to YYY. If you want to do a rolling update, you can add your route strategy to the here. And in the install progression, you can see the desired change to YYY. And the conditions will becomes upgrading. And before upgrade is done, the last applied and last known good is still XXX. For another place, and the GCP is the same. And when the desired changes, the route manager will sync the desired config spec hash to the MCA. So this field will become YYY. And before it's done, the last applied is still XXX. And the add-on manager will update the manifest work. The config spec hash will change to YYY. And when it's done, the controller will first update the status in MCA. You can see the last applied becomes YYY and the status is complete. And when all the MCA is done, you can see the status also update in the CMA. The last applied and last known good will become YYY, and the conditions will become succeed. That's the progress for rolling updates. The third example is for a canary upgrade. For example, the version still upgrade from 10 to 11, and at this time, the user want to do a canary upgrade. So to do this, you can define a route strategy with rolling update with canary. And it pointed to a placement called the canary placement. And the user also need to define a new section called canary placement. It has the same configs as the AWS placement, and it has a rolling route strategy with rolling update. With this definition, you can see the status. First is for the AWS, the desired change to YYY, and the other two field is to XXX. And the condition will become waiting for canary because the canary is not finished. And in the canary placement, the desired also changed and the status becomes upgrading. Once all the canary is done, the status will change to succeed. And the last known good and last applied will become YYY in the canary placement. And the controller will check this is done and update the last known good to YYY, and then try to upgrade all the add-ons in AWS to YYY to the last known good. The status will change to upgrading. And when all the AWS add-on are upgraded, you can see the last applied will change to YYY, and the status will become upgrade succeed. And that's the progress for canary upgrade. And during the upgrade, if user want to roll back the add-on to a specific version, I just need to roll back the name for the configs, roll back all to the XXX. And in this way, since the upgrade is not done, so actually it only roll back the desired spec hash, and the status will become still become upgrading because the controller don't know if XX to YYY is if YYY to XXX is a rollback, so the status is still upgrading, but you can know that all the add-on is trying to changing to XXX, and that's the rollback progress. And we have also considered some corner cases. The first is what if a new cluster is added during the upgrade? There are 3 cases for this. If the new added cluster belongs to the canary upgrade, canary placement, And if on that cluster there is no management cluster add-on, so that add-on should follow the install strategy defined in the canary placement to install the add-on. And if there is already a MC on that cluster, it should follow the route strategy to route the add-on to the desired configs. A second case is the new added cluster only belongs to the AWS. So if there is no MC on that cluster, it should first follow the install strategy to install the add-on. And if there is already a MC on that cluster, it should wait for the canary to finish and then follow the route strategy defined in AWS placement to route the add-on to a desired status. And third case, if the new added cluster belongs to both of them, so that cluster should first follow the behavior in canary placement and then follow the strategy in AWS placement. That's the first case we considered during upgrades. Another case is what if the cluster changes in canary frequently? Should this retrigger the rollout? The case is that the clusters in canary changed after the canary route is complete and before the AWS route is done. Should this change stop the existing AWS route and wait for the canary to complete again and retrigger the route? Our answer to this is this won't stop the route since the last known good, it didn't change. So the AWS should still route to the current last known good, and when all is done, it will continue change to the latest change. And the third case is should the desired configs change frequently, retrigger the route. The case is that the desired config change after the canary route is complete and before the AWS route is done. Should this stop the AWS route and wait for the canary to complete again and retrigger the route? And our answer to this is this won't stop the ongoing route. This example I have introduced before. For example, the config has a spec hash A, and at this time, the config with spec hash A is the last known good before the modification. And then the config changed to hash B. And it passed the canary to become the new last known good. And now all the cluster is rolling out. And during the rollout, before it's done, the config changed to C. At this time, the route to B will continue because the last known good is still B. And when the route to B is done, the canary passes the test to C. The last known good would become C, and the add-on will continue route to C. And that's the case if the config change during the rollout. I think that's all for the proposal. It's a bit long, and I will stop at the example to see if you have any questions.
Hi, Hao-Qing. Yeah, I have one question. Is that do we have some place to list the available update version? Just like, for example, for the OpenShift, you know that we have the available upgrade list, all the available upgrade version for the OCM. So do we have the place to list the available add-on version so that the user can know that which version they plan to use to put into the desired version.
Yeah, we had some discussion on this. It should be, if we add it, it should be like a hint to the status, right?
I'm
think
not
we-
sure if it is in status. Maybe it needs to. I think that yeah, when we introduce this rolling upgrade feature, so after a couple of release, we may see that the add-on version is, for example, 0.9, but the latest version can be 0.15. So they have a big gap. So there we should have place to list the available upgrade version list, so the user can choose which one they want to upgrade to.
Yeah, I think we can consider adding it. I'm not sure where to add it is best.
List the available variants in the add-on config status.
Yes, maybe.
Yeah, I think also I think this depends each add-on implementation. That
Okay. Thank you.
Yeah, I think we also need maybe a simple example of an existing add-on, like using, for example, managed service account as an example. So for the add-on developer, what they should need to consider during if they need to support multiple versions, for example, like do they need to, I think they need to define the different template for the different version, and that's must be done by the add-on developer, and otherwise they cannot. For example, when the add-on manager of MSA is upgraded to 0.11, the add-on manager of MSA also, if they can support 0.10 or the other version, they also need to maintain that version's support in their code. Is that correct?
Oh yeah, I think we can add it as a follow-up for this proposal.
Yeah, because I think the next thing that if I am an add-on developer, I also need to understand how the framework, how the library help me to use this feature.
Yes.
I also have a silly question. We see a lot of desire hash or last good known hash. But it's not that easy to look at the hash and actually know the version, right? Like when you say the hash, it's actually the like a hash of the spec, right? Is there some easy way if I look at a managed cluster add-on to know like the actual version without having to trace back all the way up? Or it's just
Yeah, I think the name might be because it also has a resource name. Maybe we need to standardize the name of the config, like it must be some prefix and also the version numbers in it.
I see, yeah, that'll make it easier. That's all my question. Thank you.
Think that would also help with verifying integrity if you have two listed as being the same version, but the spec hash is different. That would be a cause for some alarm. Potentially.
Yeah, I think so.
That was a really good presentation, and it looks like a lot of work as well. Thank you, Quinn Hao. Are there any last questions or comments for this enhancement?
Yeah, just one reminder, Haoting, maybe I think we need to put this proposal to get more in a Slack channel of community to put more feedback of the add-on developers also.
Yeah.
Yeah, I think one thing that is missing is still how easily it can be used by the add-on developer. You might need to consider it, maybe not in this proposal, but we need to consider it when we implement the framework or need another proposal to design the interface that in the framework that can be used by the add-on developer to easily use this rollout mechanism.
Yeah, yes. Maybe another proposal, because this proposal is very long.
Yeah, understand. Thank you.
Thank you so much, Quinn Hao. That was great. That was really great. Any other last? We're a little bit over. Any last minute comments, Kujang? You want to talk a little bit about the community or?
No, just we are starting to tag the 0.10 release. So I will need everyone helps to update the changelog and tag if there is a new release of the project. So I think maybe we can do it in this week and next week, so we can push the release in like next week.
Got it. Thank you, Kujang.
No problem.
Okay, we're roughly 5 minutes over. If there are any other comments or question, take care, everyone. Thank you for joining. Bye.
Bye.